Welcome to this session of Light Blade Learning Lab. Today we're going to show you just how to make sense of the profusion of zeros, datums and origins associated with this software and the machine. In the first session we talked about setting up at the top right hand corner here the datum position 00 datum for the machine itself. And then down at this bottom right hand corner we've got this little floating green square which parks itself when there's nothing on the page down at this bottom left hand corner. None of this will make sense unless you've got a basic understanding of something called Cartesian geometry. Now this does not mean you have to be a mathematician, so don't for goodness sake get turned off. This is all very simple stuff because I'm sure that most of you when you were at school got involved with graphs, and when you looked at graphs there was always a y-axis that went upwards and there was always an x-axis that went out to the right. That's probably as much as you ever learned if you didn't go very far into mathematics. Now in the bottom corner there is a point there which was 0 for the y-axis and 0 for the x-axis, and then it went from 0 to x plus, and then it went from 0 to y plus, and that was the pattern of events that you expected to see on a page. If you go beyond those 0 points, the x becomes x minus and the y becomes y minus. This Cartesian coordinate system is basically nothing more than whenever you put a point somewhere, and let's just put my cursor just there, basically that point is defined by a y plus dimension and an x minus dimension. That would define where that point was in space. The guy that invented this, a guy called Renny Dakar, as you can probably tell from his name, he was French, and well, he didn't like to make things too simple. I mean, wouldn't life be easy if everything worked the same way? Everybody understands that 12 o'clock is at top, and then we go 3 o'clock, 6 o'clock, 9 o'clock. Wouldn't it be very convenient if we had 0 degrees at the top, 90, 180, 270? No, this guy was a Frenchman. He decided to confuse people, so he started off at 3 o'clock with the zeros, and so that's 0 degrees there, and then we work backwards to 90 degrees and backwards to 180 and backwards to 270, and eventually we get round to a full circle which is 360 degrees. Now this is all very simple stuff for most of you guys, but there'll be one or two people that need just a little bit of help with their maths, so persevere with me please. So we're going to use one tool up here which is basically this rotation tool, and as you can see the Chinese have shown a very nice little symbol up there which shows it going clockwise. Now that's not particularly helpful. Now we want to place this arrow in the correct direction so that it goes y plus. Now we're going to rotate that because we've got handles around it now. We can come up here and we can click in this box and we can change that 0 to another number. Now which number do you think we should change that to? We want it to point up there at 90 degrees. Should we point it up there at 90 degrees? Let's do it. It points up at 90 degrees. But did it rotate the way that the arrow was showing? No. So what about this one here? If we want to get to 180, that's pretty easy because whether we go clockwise or anti-clockwise, we're going to ask for it to go to 180 degrees. So we can now move that to this axis here. Now this last one we want to point downwards. Now I know that it says 270 down there, and that's a clue to say that we could actually write 270 degrees up in here. But equally well, look, this is 0 plus 90. If we go from 0 to minus 90, we get to 270 as well. So instead of writing 270 in there, perhaps we can write minus 90. So minus 90 works as well. Why have I bothered to show you all this? When we set our machine up, it's the same corner as this corner here. So when it said we wanted to mirror something, The something that we were going to mirror was x plus. And of course, when you mirror x plus, it becomes x minus. And when you mirror y plus, it becomes y minus. That's why we had to tick the mirror boxes. We had to mirror the x and we had to mirror the y. So we had to make them both the opposite to a standard x and y pattern. So that's the definition of our first 0, 0, which is the machine 0, 0, which is tucked up that corner there. And it's moving in an x minus and a y minus coordinate system. So our work table is in the third quadrant. That's enough of that mathematical stuff. Let's go back to doing a simple drawing. And we'll put a circle in again because it's a very convenient form that allows us to see the handles on the corners. So we'll hold down our control key and then we'll put handles on the corners. Let's go back to the config and we'll change the system setting. If I change it to this bottom left hand corner, there's not a little man in the background with a calculator that works out how you're going to get this into your machine. There's a very complicated set of mathematics that goes on. Every object on this page is a mathematical object and it can be defined in mathematical terms. You don't have to worry about that at all because the programming system hides it all away from you. But the essence of the program is that it will be written from this green dot. So this circle will be defined in terms of x plus and y plus coordinate points. Now, if we change the coordinate system with the config system setting to that one, which is where we've got our datum over in that corner, it'll be written in x minus and y minus numbers. So I think for convenience purposes, we will leave the green dot up at the top right hand corner of all the geometry that we're going to use, because that way we will know that basically we're trying to always generally set things over here at the top right hand corner of the work table, and then everything will grow out to the left and downwards. So that's what the green dot is. The green dot is the 0, 0 point for the program that's going to be written. Now there are ways of moving this around accurately on the page. Let's just take a look at these little windows. Now this window here has got little arrows pointing up and down and left and right, and I think it's probably fairly reasonable to assume that they're something to do with the dimensions of this object. So if we set, first of all, I'll unlock the lock and I will set this dimension here to 100. So you can see that I've actually changed the X dimension to 100 and it's no longer a circle. Let's just undo that. And now what we want to do is we want to set them to exactly the same dimensions, and the way that we change the dimensions and keep them proportionately the same is to put the padlock on. If I change that dimension to 100, I have now got a 100mm circle. Now what I would like to do is to move this corner here, which is the green corner and the reference point if you remember, to a position somewhere. This could be rather confusing. Now what I'm going to do initially is to move this object to a known position in this coordinate grid, and I'm going to move it with these first two windows to a position of 100, 100. Now where do you think the object is going to finish up? Well, if you look, the clue is in the scaling at the top here, because the scaling for this drawing is working away, as I said, from 0, 0. So it's running backwards. It's not running from this corner as you might have expected. It's running away from this 0, 0 point, and it's running down the page from that 0 point at the top. So this is truly machine 0, 0, and this is a coordinate. Although we've defined it as 50, 50, in real terms it's minus 50, minus 50, but that's only for the programming purposes. But hang on, we didn't set that corner at 50, 50. We told that corner to go to 100, 100. Didn't we? Ah, that's because it hasn't moved in accordance with that green dot. This object here on the drawing has moved in accordance with this little pattern here. Now if we take a look at, if we click on this little icon next to the padlock, we get something called a select position. This is a feature that's only here in the drawing package. It's not on the machine itself. And that is what we've done. If you look, we've got center point marked here. And now if we check where the center of this object is, that has gone to 100, 100. So when we defined this dimension up here of 100, 100 for the position of X and Y, it wasn't for the green dot, it was for the center of the object. So if I choose to move that to there now, and I say OK, watch what happens up here to X and Y. What do you think is going to happen? Yep. Now we've got the green dot and the positional location the same. So although we've still got a center point for the object, that's no longer the handle for moving the object around on the page. That basically is the center of gravity of whatever shape is there. Let's, for example, just add to the situation with the square, and we'll put a box round it. You can see what I mean. Look, this has now moved so that the diagonal between this corner and this corner and this corner and this corner intersect at that midpoint there. So it's no longer the center of an object, it's the center of the box, the enclosing rectangle. So yet another confusion about how you locate things in space. At the moment we've got it set on the corner, and that generally is probably a good place to keep it, because then you'll know that your green square and your positional location, if you want to use these numbers at the top here, will be in accordance with each other. Now there is one other place where datums and zeros can be a bit confusing, and if we move to the bottom right hand corner here, we shall find that we've got something called position, and at the moment it's set to current position, but there are some other options down here. One of them is absolute coordinate. That's a very useful feature sometimes. If I save my program with this save to you file with the drawing like this, then I shall not get the option on the machine to move the datum around and press the origin button. You've specified absolute coordinates, so what that means is the circle will get drawn there and only there in relation to 0, 0. You won't have any chance of moving it around on the workpiece. So in general terms, unless you want to very accurately position something in relation to a datum point on the machine itself, and we can talk about that for location purposes later on, in general terms, stay down here with this thing called current position, which allows you to be totally flexible with where you place the origin point or the head on the machine. So bear in mind that the head, the machine head, is actually going to sit at this green point here. Most people will grab hold of the head and they will drive the arrow key, and so that the head sits there. And their immediate reaction is, okay, my first circle is going to be here. You can clearly see that it isn't going to be. You're going to be cutting off of the work area and you're going to get an error on your keyboard. It says slop error. Basically, I think slop in Chinese is probably meaning idiot. So that's one of the dangers of having a system which is not intuitive. Driving the head to the top right hand corner is far less intuitive as far as positioning your work than it is if it's on the top left hand corner, which is where everybody conventionally works from, reads from, writes from. To try and overcome this problem, what I would generally say is try and get your mind around the idea that your first object will be set there and you work right to left and down the page rather than left to right across the page. Now, although it seems like a lot more, in reality that's only 4 datum points, 0, 0 positions and origins that you've got to think about. So it's not too bad, but the problem is just trying to make sure you understand them in relation to each other and the work area. So we haven't been near the machine in this session, and it's possible that we might not go near the machine in the next 1 or 2 sessions. So we've really got to look at all the tools that we can use before we start drawing anything or before we start programming seriously any objects. So today has all been about the relationship between this drawing page and the work area. But that's an important set of fundamentals that you really must try and master. Well, thanks for your attention. We'll see you next time.